All right, so we use the vertical line test to see if it's a function. All right, I've got two graphs here, one that's like a U going up that way, one that's like the letter C, right? And the vertical line test says if you can draw a vertical line and it goes through more than one point on the graph, then it is not a function. All right, it's only a function if it goes only through one point. So is there anywhere, that does not right, is there anywhere that I could draw a vertical line here for this one? That one doesn't write either. Is there anywhere I could draw a vertical line? That one barely writes. Let me grab the marker I've got over here. Oh, here's the other one. Here's the one I was using. Is there anywhere on this graph that I could draw a vertical line and it would go through more than one point? Nope. So this one passes the vertical line test, so this one is a function. I'm going to abbreviate function like that, all right? But what about this guy? I start drawing vertical lines on this, man, it's crossing multiple points in several places, right? So this is not a function because the vertical line crosses more than one point on the graph, all right? Any questions about that? So by this definition, is the graph of a circle a function? It's not, right? Because if you graph a circle, you're definitely going to be able to draw a vertical line and go through more than one point, right? But is the graph of a line like that, is that a function? Is there anywhere that I can draw a vertical line and cross the line in more than one place? Nope, so it's a function, right? That is a function. Okay, isn't that really easy? You just got to memorize what the rule is there, but it's super easy to do. All right, so I show you a graph. Is this a function? You just say, can I pass a vertical line through more than one point? If I can't, then yes, it is a function. All right, so let's go on to the next topic in this chapter, which says we're doing systems of equations again. You had an example of this on the test last week. I think it was. I don't think it was this week. So not the test, the quiz that you did last week, right? So we had a problem that was something like, I'm just doing this from memory, but it was a problem that was something like RF times TF equals RS times TS, right? And they told us, I think TF was 5 and TS was 6. And then they also told us that RS equals RF minus 19 or something like that. I don't remember. Maybe that was 16. I think it was 16. Doesn't really matter. And so I asked you to tell me what RS and RF were. That was what the quiz asked you. All right? And so what you did was you just plugged in the values that we knew. You knew that TF was 5, and you knew that TS was 6 according to that. And then you also knew, I think this one was listed actually like this. So you had to not be confused by the fact that the RS came afterwards. But from that equation down here, we see that RS is equal to this right here, so we could actually replace RS with that, and we get that RF minus 16 times 6 equals all of that. And so now we have an equation that only has one variable in it, and when you distribute and you move the variable to one side, you can actually figure out that the value of RF is, if I did the math right here, it turned out to be positive 96. I don't know that I did the math right. Oh, that was right. I do remember it was like that because then to find RS, so this was RF, and then to find RS, you just took RF and plugged it in right here, and you said 96 minus 16 is what RF is equal to, so RF ended up equaling 80. All right, you guys remember doing those? All right, so you just plug in what you know until you can make an equation that only has one variable in it. And anytime you have an equation with one variable, you can always solve for that one variable. Okay, so this is the same exact stuff that we're doing with this chapter here. It's just they don't quite write this, like they don't give this as, make this as obvious, all right? Everything else is the same, so let me show you what I'm talking about. So they gave us an equation like this. They said R1 T1 plus R2 T2. They should have done R2 D2. Man, they blew that one. That was a wonderful opportunity there, especially so close to May the 4th, right? 360. Are we going to get to dress up on May the 4th? Does anybody know? Any of you nerds in here know? Answer that. Do I have any nerds in here? How many of you know that May the 4th is Star Wars Day? Okay, so that's a little nerdy, all right? You're just going to have to admit, there's a little bit of nerdiness. May the 4th be with you, right? So R1, they tell us is equal to 30. They tell us that R2 is equal to 40. See how much this looks like what we had right here? Right? We've got some equation with 4 variables in it. They tell us explicitly what the value is of 2 of the variables, just like we had right here. But it's the last equation that's slightly different, right? So the last equation they give us is T1 plus T2 equals 10. So unlike this one here, where they say RS is equal to this, they don't tell us that T1 or T2 are equal to anything specifically. But does everybody see how easy it would be to rearrange this equation just slightly? And you be able to tell me using that equation what T1 is equal to? If I told you to solve for T1 in that equation there, what would you say T1 is equal to? When I tell you to solve for a variable, what does that mean? Anytime I say solve for a variable, if I give you x minus 3 equals 4, how do you solve for x?
Plugging in value.
We're going to plug in a value here? What value are you going to plug in to solve for x?
Well, not with that specific one, but...
But what about for this one? Just focus on this right now. How would I solve for x if I asked you to solve for x? Will?
You put x by itself.
I want x on one side all by itself, right? That's what it means to solve for a variable. So I would just I would add a 3 to both sides, right? And I would say x equals 7. And I've solved for x, right? Now, let's say I told you to solve for T1 here. It means the exact same thing. It means I want T1 on one side of the equation all by itself, right? How would I do that? Yep, Alexa?
Subtract T2.
Yeah, so let's subtract the T2 from both sides, right? And when I do that, I get T1 equals 10 minus T2. Does everybody see that? See how easy that was? Now, I've solved this equation here to get exactly what they gave us here. I know what one of these variables is equal to. So I know what R1 is equal to, I know what R2 is equal to, and I know what T1 is equal to. And I can plug all of that in this equation, and when I do, now I've got an equation right here that only has one unknown variable. And if I've got an equation with one unknown variable, I can always solve that equation. Okay? So let's plug it in and see what we get. R1 is 30, so we're going to go 30 T1, right? Just taking this value here and plugging it in for R1. What's R2? Alexa goes up here. What's R2?
40.
Huh? 40. R2 is 40, right? So we're going to plug that in for R2. 40 T2 equals 360. But that's not all that I know, right? I just solved for T1, so I can also plug that value in over there for T1. So I can say 30 times 10 minus T2 plus 40 times T2 equals 360. Now, did I lose anybody going from here to here? Do I need to explain that, the steps that I took to do that? Is that clear? All right. What do I have right here? I've got an equation with a single unknown variable, right? T2 is the only thing that's unknown. And anytime I have an equation with one unknown, I can solve that. What am I going to do? How am I going to get rid of the parentheses right here? Distribute, right? So 30 times 10 is 300. 30 times negative T2 is negative 30 T2, right? Plus 40 T2 equals 360. I'm going to keep my T2s over here on this side, so I'm going to get 10 T2 I'm gonna move 300 over here. 10t2 equals 60. Did I lose anybody in those steps? You guys tracking with me? Remember to put on the brakes if I lose you somewhere. We've been doing this a lot all year long, so I'm getting faster and faster with it, trying to. But stop me if I lose you. I'm just combining like terms, right? Getting my variable on one side and my numbers on the other side. So now I have to divide both sides by 10, so I get T2 equals 6. So that's T2. And if I want to find T1, how do I figure out what T1 is?
You plug it into the equation on the far right.
Yeah, so I've got an equation already right here that tells me what T1 equals, and all I need to know is what T2 is. So T1 equals 10 minus the T2 I just solved for, which was 6. So T1 equals 4. So now I've answered the question. They wanted to know what T1 and T2 was. I've figured out what both of those are. Any questions about these steps here? Exactly the same thing we did here, except we just had to solve this equation here for one of those variables. And then I could plug it all in over here. All right? So it's just kind of one extra step in this one. You'll have to solve a small equation for a variable, and then you can plug everything you know into the bigger equation, and you'll be able to, that will allow you to solve for one of the variables, like get an actual numeric value for one of the variables. Any questions about that? Guys, you know how you're going to get good at this?
Practice.
You're just going to have to practice it, right? This stuff is just going to be so easy and second nature if you practice it. But you've got to work problems. You're never going to get good at it if you don't work the problems. You have to work the problems. You have to understand it. If you don't get it right the first time, when I look at your homework and I see that you missed a couple, 2 or 3 or whatever, I hope you're going back and redoing those, right? Because that's how you're going to get good at it is, all right, let me see if I can do it without looking at the answer and get the right answer. You got to figure out the mistake that you made and then rework the problem. All of you guys can do this stuff, but it's going to depend on you investing the time to work more problems if you're still struggling with it, okay? I got a student in my geometry class this year that has aced just about everything that I've given this student. Done really well in the class, definitely has a high A in the class. We're doing an algebra review at the end of the year just to kind of get the class ready for taking Algebra 2 next year. And I was shocked. I was just grading the quiz, and I was shocked at what this particular student missed. And the reason he missed it is because there was some gap in the Algebra 1 stuff whenever he took this. It's a really easy concept, but he just didn't work enough problems so that he remembers how to do it. If you'll work the problems, it'll stick with you, all right? And I told you guys before, standardized tests, ACT and SATs, predominantly geometry. It's mostly stuff like this. It's mostly what they're testing you on on those standardized tests. And all 3 of my kids, because they did so well on the ACT, all 3 of them got substantial scholarships to the schools that they're going to, just based on ACT scores alone. So it'll help, all right? Some schools, they're like, some schools aren't requiring it. That's true. They're not requiring it now, but they're still offering scholarships based on you doing well in that. And if you're going to do well in the math portion, you have to know algebra. Okay? By the way, I'm teaching an SAT prep class. If anybody wants to take it, it's through Konos. I don't know if we may offer, well, I think we offer one here like all year long. So, but I am teaching like a 2-week one over the summer. If you guys are interested in that, let me know. Because it starts like immediately, we do it immediately after school ends. So the last 2 weeks in May, and then we offer another one, which is the first 2 weeks in August, I think. So if you got a test coming up, I do teach a separate class for that if you're interested in taking it. All right. Okay, let's move on to quadratic equations and solving quadratic equations. Now, we've done quadratic equations before. Who can tell me what a quadratic equation is? Okay. Who can not tell me what a quadratic equation is? I'm just making sure you guys are actually listening, right? Sometimes I'm not sure. A quadratic equation is an equation that looks like this. Right? We've seen those before. And remember we had to learn how to factor those? Do you guys remember how we factor it? Who thinks that they could factor this guy? Anybody feel like they're particularly strong in that area? What goes here and here?
The two X's.
The two X's, right? That's the easy one. And then the numbers that we put here, if you multiply those numbers together, it's got to equal negative 18. If you add those numbers together, it's got to equal negative 3. All right? So what two factors of 18, when added together, what two factors of negative 18, when added together, will give you negative 3?
Would it be positive 6? No. Negative 6 and positive 3.
Negative 6 and positive 3. Good. Does everybody see that? These numbers multiplied together give you negative 18. When you add these two numbers together, you get negative 3. Right? That's as simple as it is. That's all you have to think about with that. All right? So that's all we're doing in this chapter, but we're adding one additional concept to it, which is also super simple. All right? If they give this to you like this, then we can solve for x. What did I tell you guys earlier? If we have an equation that only has one variable in it, we can solve for that variable. All right? And here, we only have one variable, just the x. But how do you solve for it when you've got an x squared term? The way you solve for it is you factor it like this, just like we did here. The whole thing's set equal to 0. Let me ask you a question. If I told you that a times b was equal to 0, what has to be true in order for that equation to be true?
They're both 0?
They don't have to both be 0, but
Well, one has to be.
one of them has to be 0. Does everybody see that? The only way you can multiply something together and get 0 is if one of the things you're multiplying by is 0, right? So either for this equation here to be true, either a has to be 0, right, or b has to be equal to 0. Does everybody see that? That's exactly what we're going to do here. We're going to say if all of this is equal to 0, then that means either x minus 6 is equal to 0 or x plus 3 is equal to 0. And then I'm going to solve that. If x minus 6 is equal to 0, what does x have to be? How do we solve that equation?
X has to be 0, right?
No, x minus 6, yep,
6.
we add a 6 to both sides, right? And when we do that, we get x equals 6. Does everybody see that? Isn't it true that if I plug in 6 for x right here, 6 minus 6 is 0? And then for this one, x has to be equal to negative 3. You guys see that? So that's all we're adding to this. We're just saying, we're factoring, just like we've done in the past, a quadratic equation. And those factors will be set to 0, and then we solve those to get what x would be. All right, so let's do another example from the book. Let's try, let's do x minus 56 equals negative x squared. All right? Now, if what we're trying to do is the same kind of thing that we did right here, what do you think would be the first step in this? We need something that looks like this guy here. So what are we going to have to do?
You have to move the X.
Huh?
You have to move the X.
We're going to move this x squared. Why am I moving this guy? I have to basically get everything on one side. I want 0 on one side and everything else on the other side. Why am I choosing to move this over to this side instead of moving these two guys over to this side?
Because you want the one that's squared in front.
I want it in the front and I want it to be positive, right? So I'm going to move this guy over here, and so when I do that, I get x squared plus x minus 56 equals 0, right? Because when I move it to the other side, I have to change the sign. Does everybody see that? Now we've got the exact same type of problem that we had here. So we're just factoring this guy, We put x's in the front here, and I'm thinking which factors of negative 56, when added together, will give me a positive 1? What are some possible factors of 56? 1 and 56. It's divisible by 2, so I could say 2 and 28, right? But those are not going to add together to give me a positive 1. And it is negative 56, so I could do like negative 2 and positive 28, but that's not going to work. What factors of 56 can be added together? Negative 56 can be added together to get a positive 1. There should be one other. Actually, 56 is divisible by 4. So it's 14. 14 times 4 is 56, but I can't take the difference of 14 and 4 and get a positive 1. Does everybody see? Yep. Negative 7 and positive 8, right? Does everybody see that? So if I do, Madeline's already on there. If I do negative 7 and positive 8, multiplying those together will give me negative 56. Adding those together will give me the positive 1 that I need for the coefficient of the x. Yep. And so now we're going to set both of those equal to 0 in order to see what x has to be. And so when I solve for it, I get x equals 7 and x equals negative 8. Okay? Does that make sense? Does it not make sense? Does it make sense, Liliana? By the end of the class, we got 2 more weeks. You're going to be talking louder than everybody else. It's going to happen. If I offer you chocolate, could I get you to talk more? Maybe? Okay. Oh, all right. A fellow chocolate lover. That's good to know. Speaking of that, I always like to bring snacks the last day. You guys be thinking about what your snack requests are. All right? So I'll bring something for us to snack on while we're taking our fight off. Just no snack guts on my test. All right? Try to keep your fingers clean as you handle the test. All right. So that was lesson 89, was it? Oh, sorry, that was lesson 88. All right. So we are going to do 89. 89 is they call them value problems. It's very similar to the problems that we've already done with. It's basically the same problems that we've done with dimes, dimes and nickels and quarters and nickels and all that sort of stuff. It's the same exact idea. If those make sense to you, these should make perfect sense to you as well. So let's just do an example and make sure we all get it. Page 372, it says airline fares for flights from Tifton to Adel. Does anybody know where Tifton and Adel are? My dad used to sell insurance when I was a little kid in Adel. It's all in South Georgia, so it's like kind of down near Valdosta, Georgia, if you're familiar with Valdosta. So this is a Georgia problem. I thought that was cool. I don't know that there are any flights from Tifton to Adel. Maybe little tiny commuter flights. Certainly wouldn't be big planes because those aren't big places. Tifton's grown, but Adel's still tiny. So anyway, the flights are $30 for first class and $25 for tourist class. So yeah, it's got to be a tiny plane, right? $25 and $30, and plus this book is, I don't know how old, right? I don't know, 90s maybe? When was this published? 2003, all right, so it's been at least in this century. If a flight had 52 passengers, who paid a total of $1,360, how many first class passengers were on the trip? Now when we did those dimes and quarters or dimes and nickels problems, what were the variables that we used in those problems? Did you guys have one of those problems on this quiz? Do you remember?
It was n and then had a small d.
Yeah, so we used like the n to represent the number of, and then we used a little variable to say the number of dimes or the number of quarters. We're doing the exact same thing here, but it's not dimes or quarters that we need to know the number of. We need to know the number of first class tickets versus the number of tourist class tickets. Okay? So I'm going to do NF for, isn't there a rapper named NF?
Yes.
Yeah.
Okay, I thought so. NF He's not the one that does church class. No, that's KB, right?
That's the parade.
KB and Lecrae, right? Yeah. Okay. So NF and then my wife is annoyed by that song, but I love it. I like the little kind of video game, old video game sounding thing at the beginning too, but she doesn't like that at all. NF is going to be first class, and then NT is going to be tourist class. Okay? So this represents the number of first class tickets, this represents the number of tourist class tickets. And how can we build a couple of equations using those values? What about the fact that they tell us that a total of 52 passengers were on the plane? Can I use these variables in that 52 at all? If there's 52 passengers on the plane, that must mean that they bought 52 what?
Tickets?
Total tickets, right? And if this represents the number of first class tickets, and this represents the number of tourist class tickets, then does everybody see I can say the number of these plus the number of these has to equal 52? Does that make sense? Does that make sense, Hannah? Yeah? Okay. All right. You're next. You're on my radar now. What are you? Can you be bought by chocolate as well? Oh, not a chocolate fan. Okay. All right. I'll have to get to the bottom of that. It's like my son Josh. I'm pretty sure we must have dropped him on his head at some point because he's not a chocolate fan. Something's wrong. I wasn't at home. My wife probably, I don't know, played basketball with him or something as a baby. Something's off if you can't be bought by chocolate. So the next question is, the cost of the tickets they bought was a total of $1,360. So how can I use that fact? And they also tell us what the cost of each of the tickets were, right? It's $30 for first class, $25 for tourist class. How can I use that fact and the total amount of the money that was spent on the flight to build another equation? Think about what we did with dimes and nickels, right? If I told you that we had some number of dimes and some number of nickels, and when you added them all up together, that it equaled 75 cents. What equation could you build using the number of dimes and the number of nickels? Or we'll say $1.25, all right? Remember what we did is we said, well, 10 times the number of dimes, because the value of the dimes is 10 cents, plus 5 times the number of nickels, because the value of nickels is 5 cents, has to equal our 125 cents, which is what $1.25 is, right? Does that make sense to you guys? You guys can count with dimes and nickels, right? It's not hard. All right, well, let's count instead with the value of our first class and tourist class tickets. Does everybody see that if the first class tickets were $30, then 30 times the number of first class tickets and the tourist class tickets were $25 plus 25 times the number of tourist class tickets. When I do that math there, it's got to equal what? According to the problem. Just like the value of the dimes times the number of the dimes plus the value of the nickels times the number of the nickels has to equal the total amount of money I have. Likewise, the value of the first class tickets times the number of first class tickets plus the value of the tourist class tickets plus the number of tourist class tickets has got to equal the total number of money that was spent, which they tell us was $1,360. All right, so there's our two equations, and we have two unknowns. How do we solve something like this? We've got two equations and two unknowns. This is just a system of linear equations, and we have two possibilities. We can either use substitution, Liam, there we go again, right? Or elimination. That's it. That's our option. And we know how to do that. I'm not going to waste the time doing that again. I just wanted to make sure that you guys saw how to set one of those up. Does that make sense, how to set it up? Again, you're just going to have to practice it. Practice it in your homework, and this is no different than this here. It's just we're very familiar with the dimes and nickels and quarters values, so they didn't have to give us the values. In these problems, they're going to have to give us the values. They're going to have to tell us that for the first class tickets, they're worth $30, and for the tourist class tickets, they're worth $25. Okay? The process from there on is exactly the same. I feel like we've already done this, so I'm just going to go over it very quickly. So you guys can tell me if we haven't done this before. If I asked you to graph that inequality on a number line, haven't we done that before? Does that seem familiar to you guys? I thought we did that in one of our past chapters. Does anybody know how you would graph that on a number line? You first have to solve for the x, right? Because it's really hard to graph unless you get the x on one side all by itself. So how would I solve for x in this? Got several names not on the board, so here's your chance.
You just like move it to the other side and make it a negative or a positive.
So move the x over,
Uh-huh.
right? Yep, so we could do that. So
Or
if,
just move the 4.
or we can move the 4. All right, I'm going to let you pick which way you want to go, Cohen.
I guess move the 4 to the other side.
Okay.
Might move 6 as well.
All right, so we'll leave this here like that, right? We'll move the 4 over, so now we have negative x. 6 minus 4 is 2. So we just work with it just like it's an equation, right? So we're almost done, but we want to get rid of that negative sign in front of it because that's confusing us. How do I get rid of the negative sign? If I have a negative x,
And you just put it over 1.
so put it over 1 like this?
Or under 1.
Huh?
Like under 1, and then we'll change it.
So there's kind of two options. Two ways you can think about this. Either you want to multiply both sides by -1 or divide both sides by -1. Do you guys see that? Do you see if I divided both sides by -1, that's going to get rid of the negative sign there, so I'm just going to be left with x. But always with equations, whatever you do to one side, you have to do to the other side, right? So what have I got over here on this side? 2 divided by -1 is -2, right? Now, here's the big gotcha when you're working with inequalities, all right? There is a rule that you can never forget with inequalities. It's the only thing that makes inequalities different from equations. They're called equations because they have an equal sign in the middle, right? Inequalities have a less than, greater than sign in the middle. The one difference between inequalities and equations is that if you multiply or divide both sides by a negative number, you have to flip the inequality. So that's the one rule. If multiply or divide both sides by a negative value, must flip in the inequality. All right, so this was less than or equal to. We have to change it to greater than or equal to. Okay? That's the only gotcha with working with these. And so now we should remember how to graph that. How do I graph that on a number line? Can anybody tell me?
You start at -1 and then continue to the right.
Not -1.
-2.
-2, you're right. So -2. Since it's greater than or equal to, we're going to fill in the circle, right? And then it's greater than, so we label it this way, right? Some people like to put it above the number line, like they write it like this, right? Which is fine too. All right? Besides just remember making sure you know how to do this, the thing that this adds to it is they will give us the domain, all right? So this is true if they gave us a domain of all reals, all right? So remember what domain is? Domain is the possible x values. So if they tell us the domain is all reals, then we say, yeah, it includes every number that's greater than or equal to 2. But if instead they had given us a domain and said it's the domain of integers, what are integers? You guys remember what integers are? know we've talked about it at some point. If any computer programmers in here, you definitely know what an integer is. Do you know?
Negative and positives.
It includes negative and positive, but it's negative and positive numbers that don't have a decimal. All right, so it's like from negative infinity, -3, -2, -1, and then 0, 1, 2, 3, 4, 5, and you just keep counting, right? So when your domain is integers, you would label that like this. You would say,
Could you just fill in each number?
you fill in each number, exactly. So we would say, at each of these, we couldn't do the line all the way across. We would put a dot there, 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 and then we would just kind of fill in the arrow here to say we keep going with that. Okay? Does that make sense? So with integers, only fill in the whole numbers. If it's all reals, then you do like what you've always done before, where you put the line going all the way. Okay? All right, we're a little bit over time. Sorry about that. I will send you guys the homework assignment, and I hope you have a great rest of your week. I hope you do wonderful on your college finals. Anybody else got college finals this week? All right, see you guys next time.